Hello everyone, welcome to today's chemistry class. Today we are going to see a new topic or a new theory related to bond. It is known as valence bond theory. In the last classes we have discussed VSCPR theory, so it is a little advanced theory compared to VSCPR3. So we can see what is valence bond theory, or it is also known as VBT. Abbreviation is VBT. It is a quantum theory of covalent bond. Quantum theory. Okay, valence bond theory. The first quantum mechanical model to explain the nature and stability of a covalent bond was formulated by Hitler and London in 1927, or simply we can say in 1927 Hitler and London proposed valence bond theory or VBT, and this theory was then modified by Pauling and Slater in 1931. This theory is commonly known as the valence bond theory or VBT, and the main postulates of VBT are as follows. First one, a covalent bond. It is based on the covalent bond formation. It is formed due to the overlap of the outermost half-filled orbitals of the combining atom. So, a covalent bond is formed by the overlapping of half-filled atomic orbitals. And the strength of the bond is determined by the extent of overlapping. So, if the overlapping is that much high, then the bond is also very strong. That is the meaning. And the second postulate is the two half-filled orbitals involved. So, the main point is the orbital which take part in bonding are half-filled orbitals. The two half-filled orbitals involved in the covalent bond formation should contain electrons with opposite spins. So, spin means direction of rotation. So, the electrons should have opposite spin. The electrons which take part in bond formation should have opposite spin. The two electrons then move under the influence of both the nuclei. The completely filled orbitals do not take part in the bond formation, and the main point is the completely filled orbital. That means in an orbital two electrons are possible. So, if an orbital is having two electrons, it does not take part in bonding. That is the meaning. So, according to valence bond theory, a covalent bond is formed by the overlapping of outermost half-filled orbitals, and the strength of the bond is determined by the extent of overlapping. And the two half-filled orbitals which are involving in bonding should have electrons with opposite spin. And the last postulate is the completely filled orbitals do not take part in the bond formation. Only half-filled orbitals take part in bond formation. That is the main point. Half-filled orbitals take part in bond formation. And the next point is, an s orbital does not show any preference for direction. The non-spherical orbitals. That means we have studied that we have s, p, d, f orbitals. So, in s orbital it is in spherical shape. So, s orbital does not show any preference for direction of bonding. Okay. The non-spherical orbitals such as p and d orbitals tend to form bonds in the direction of maximum overlap. So, it is having some directions because it does not have spherical shape. The shape of p orbital is dumbbell. So, it has along the orbital axis the bond is formed. Okay, in the case of p and d orbitals. Okay, p orbital has dumbbell, d or double dumbbell. Many shapes are there for these orbitals. The fifth point is, between the two orbitals of the same energy, the orbital which is non-spherical, example p and d orbitals, forms stronger bond than the orbital which is spherically symmetrical, example s orbital. So, between the two orbitals of same energy, the orbital which is non-spherical, example p and d, forms stronger bonds. So, p and d orbitals form stronger bonds than the s orbital. Simply we can say p and d orbitals form very stronger bond than the s orbital. And the sixth point is the valence of an element is equal to the number of half-filled orbitals present in it. The valency of an element is equal to the number of half-filled orbitals present in it. Okay, number of half-filled orbitals. In the valence bond model, the stability of the molecule is explained in terms of the following following type of interaction. So the following interactions are play a vital role in the stability of the molecule. So electron-nuclear interaction, electron-nuclear attractive interaction, electron repulsive interaction, nucleus-nucleus repulsive interaction. So we can see first one, electron-nuclear attractive interaction. The electrons of one atom are attracted by the nucleus of the other atom. The electrons of the one atom are attracted by the nucleus of the other atom. So when two atoms take part in bonding, ഒരു ആറ്റത്തിൻ്റെ ഇലക്ട്രോണും മറ്റേ ആറ്റത്തിൻ്റെ ന്യൂക്ലിയയും തമ്മിലുള്ള അട്രാക്ഷൻ ആണ് ഉദ്ദേശിക്കുന്നത്. ദ അട്രാക്ഷൻ ബിറ്റ്വീൻ ദ ഇലക്ട്രോൺ ഓഫ് ദി വൺ ആറ്റം ആൻഡ് ദ nuclei of the other atom, because nucleus is having positive charge and electron is having negative charge. That is an attractive interaction. And the second one is electron repulsive interaction. So electrons of one atom are repelled by electrons of the other atom. So രണ്ട് ആറ്റത്തിൻ്റെയും ഇലക്ട്രോൺസ് തമ്മിലുള്ള റിപ്പൽഷൻ ആണിത്. And the third point is nucleus repulsive interaction. The nucleus of one atom is repelled by the nucleus of the other atom. So nucleus having same charge, positive charge. So nucleus repulsive interaction between two different atoms, between the two atoms. These are the main interactions. Okay, so here you can see the figures. Okay, so attractive force between the electron and the nucleus. First of all, between the electron and nucleus. Okay, then second one is repulsive force between the nucleus. Okay, second remark is repulsive force between the nucleus, and the third line is also attractive force between the nucleus and the electron, and the last repulsive force between the electrons. Okay, the attractive and the repulsive interactions oppose each other. When the attractive interactions are stronger than the repulsive interaction, the amount of energy is released. Due to the lowering of energy, the molecule becomes stable. Or simply we can say, if the attractive interactions are stronger than repulsive interaction, the molecule is stable. That means if the attractive interactions are more than that of repulsive interaction, the molecule becomes more stable due to the large amount of energy, due to releasing of the large amount of energy. So when the energy is lowered, the molecule becomes stable. എനർജി റിലീസ് ചെയ്യുന്നു അട്രാക്ഷൻ കൂടുമ്പോൾ. അപ്പോൾ എന്ത് സംഭവിക്കുന്നു? എനർജി പോയി കഴിയുമ്പോൾ ദ മോളിക്യൂൾ ബിക്കംസ് സ്റ്റേബിൾ ഓർ ബോണ്ട് ബിക്കംസ് സ്റ്റേബിൾ. ദ നെക്സ്റ്റ് വൺ ഈസ് ടൈപ്സ് ഓഫ് ഓർബിറ്റൽ ഓവർലാപ്പ് or valence bond theory, orbital overlap, types of orbital overlap. We have already studied that we have s orbital, p orbital, d orbital and f orbital. Okay, s orbital, s means sharp, p means principal, okay, d means diffuse, okay, that is spd. Various, so we discuss only sp. Various types of orbital overlap leading to the formation of covalent bonds are, first one, ss overlap. In ss overlapping, the overlapping between two s orbitals, simply that means overlapping between two spherical s orbitals. In this type of overlap, half-filled s orbital of the two combining atoms overlap each other. So in this ss overlap, half-filled s orbitals of the two combining atoms overlap each other. ഇവിടെ രണ്ട് എസ് ഓർബിറ്റലിൻ്റെ ഹാഫ് ഫിൽഡ് ഓർബിറ്റൽസ് ഓവർലാപ്പ് ചെയ്യുന്ന രണ്ടും സ്പെറിക്കലാണ്. യു ക്യാൻ സീ ദ ഫിഗർ. ഫസ്റ്റ് സെക്കൻഡ് ഫിഗർ യു ക്യാൻ സീ ഹിയർ. ഫസ്റ്റ് then s plus s gives ss overlapping. S orbital plus s orbital gives ss overlapping. So you have to note down this structure also, and you have to draw the diagrams also in the notebook. Okay. The second one is sp overlap. Okay, sp overlap. Here sp overlap means overlapping between one s orbital and one p orbital. Overlapping between one s orbital and one p orbital. Here a half-filled s orbital of one atom overlaps with one of the p orbitals having only one electron in it. So here it is nothing but, so here in this figure you can see, this figure you can see overlapping between s and p orbital. This figure, okay, this one. Overlapping between s and p orbital. Here one s is overlapped with other p orbital, so you are getting sp overlapping, okay. So sp overlapping, that's second one. Simply we can say this one, sp overlapping. And the third one is pp overlap along the orbital axis, okay. pp overlap, that means simply we can say overlapping of two p orbitals. This is called head on or end to end linear overlap. That means overlapping in a head on head overlapping. Here the overlap of the two half-filled p orbitals takes place along the line joining the two nuclei. This is shown in this figure. So this is a figure, okay. So you can see this one, this is a figure. So when p orbital plus p orbital gives pp overlapping, head on head overlapping, okay. That is all about the pp overlapping. Next one is that is pp. So last case was pp head on head overlapping, and the fourth one is pp sideways overlapping. Third one was pp head on head or through internuclear axis overlapping. So now sideways. So മുമ്പേ നമ്മൾ പറഞ്ഞത് പി പിയിൽ അതിൻ്റെ ഇൻ്റർന്യൂക്ലിയർ ആക്സിസ് കൂടെ ഫുള്ളായിട്ട് സെൻറ്ററിൽ കൂടെയായിരുന്നു. സോ നിങ്ങൾക്കിവിടെ മനസ്സിലാക്കാൻ പറ്റും. സോ നിങ്ങൾക്ക് മനസ്സിലാക്കാൻ പറ്റുന്നുണ്ടോ? ഇതിൻ്റെ ഇൻ്റർന്യൂക്ലിയർ ആക്സിസ് കൂടെ ഈ സെൻറ്ററിൽ കൂടിയാണ് ഓവർലാപ്പിങ് പോകുന്നത്. ഇവിടെ ഈ ഫിഗറിൽ മനസ്സിലാക്കാൻ പറ്റും. ഈ സെൻറ്ററിൽ കൂടി ഇങ്ങനെ നേരെയാണ് പോകുന്നത് പി പി ഓവർലാപ്പിങ്. പക്ഷേ ആൻഡ് ഇൻ ദ സെക്കൻഡ് കേസ് നൗ ഇറ്റ് ഈസ് ത്രൂ സൈഡ് വേസ് ഓവർലാപ്പിങ്. ഇൻ ദ ഫിഗർ യു ക്യാൻ എക്സ്പ്ലെയിൻ ദാറ്റ്, യു ക്യാൻ സീ ദാറ്റ്. So PP sideways overlap. This is called lateral overlap or sidewaying overlap. In this types of overlap, two p orbitals overlap each other along a line perpendicular to the internuclear axis. That means the overlapping perpendicular to the internuclear axis. That is, the two overlapping p orbitals are parallel to each other. അപ്പോൾ രണ്ട് ഓർബിറ്റലും പാരലൽ ആയിരിക്കും ഈ ഓവർലാപ്പിംഗ് നടക്കുമ്പോൾ. This is shown in figure. This is a figure. So one p orbital overlaps with the other p orbital through sideways, not in the internuclear axis. So pp sideways overlapping, okay. So we have discussed ss overlapping, sp overlapping, and pp internuclear axis overlapping, and pp sideways overlapping, okay. Now types of covalent bond on the basis of internuclear axis and sideways overlapping. On the basis of internuclear overlapping and sideways overlapping, we can classify covalent bonds into two main categories: sigma bond and pi bond. Symbols are given here: sigma bracketal sigma symbol, pi bracketal mathematical pi symbol, okay. Sigma is also same, that is small sigma in Greek symbol, okay. The overlapping of orbitals is possible in two ways that we have already discussed: along their orbital axis, so that the electron density along the axis is maximum, and the second one is along the direction perpendicular to the bond axis due to the sideways overlapping. So first one is overlapping through internuclear axis and overlapping through sideways overlapping. So the overlapping in internuclear axis and that bond is formed is known as sigma bond, or sideways overlapping is known as pi bond, depending upon the manner in which the two atomic orbitals overlap with each other. Two types of bonds are formed. These are called sigma bracketal sigma symbol and pi bracketal pi bond is formed, okay. So a covalent bond is formed due to the overlap of orbitals of two atoms along the line joining the two nuclei. That means along the internuclear axis. So a covalent bond is formed due to the overlap of orbitals of the two atoms along the internuclear axis is called a sigma bond. For example, the bond formed due to ss, sp and pp overlap along the orbital axis are sigma bond, okay. Here z axis is not taken, so here you can see the figure also, okay. You can zoom it and you can see, we have already discussed these figures. A covalent bond formed between the two atoms due to the sideways overlap of their p orbitals is called pi bond. A covalent bond is formed between two atoms due to the sideways overlap of their p orbitals is called pi bond. That is also we have discussed earlier, okay. The figure. Next one, comparison of sigma and pi bond, okay. Or this is a very important topic, comparison or differences between sigma bond and pi bond. So sigma bond, first of all, first point, it is formed due to the axial overlap of the two orbitals. The overlap may be SS, SP or PP. That means the bond is formed through internuclear axis. And pi bond, this is formed by the lateral or sideways or of two PP orbitals, okay, or parallel. It is due to the formation of lateral or sideways overlapping of PP orbitals only PP orbitals. And in sigma, SS, SP and PP are possible. And in sigma, second point is there can be only one sigma bond between atoms. Okay, there can be only one sigma bond between the atoms. And pi bond, there can be more than one pi between the two atoms. That means two pi bonds are possible between the atoms. Third one, the electron density is maximum and cylindrically symmetrical about the bond axis. So the electron density is symmetrical about the bond axis. Third point, the electron density is high along a direction at a right angle to the bond axis. So electron density is at a direction right angle to the bond axis. Fourth point, the bond is very strong. Sigma bond is relatively strong and pi bond is relatively weak. Fifth one, free rotation of atoms about sigma bond is possible. Rotation of sigma bond is possible. And pi bond, free rotation about the pi bond is not possible. That means rotation of pi bond is not possible because the bond will break. And the sixth and the last point is sigma bond can be formed independently. That is, there can be a sigma bond without any pi bond. Okay, that means sigma bond can form independently. Okay. The pi bond is formed only after the formation of a sigma bond. So the pi bond is formed only after sigma bond has been formed. So these are the points, differences between sigma bond and pi bond. So sigma bond formation through internuclear axis, pi bond formation through sideways overlapping. There can be only sigma bond, only one sigma bond between atoms. There can be more than one pi bond between the atoms. And the electron cloud is perpendicular to the axis in the case of pi, and cylindrically symmetrical in the case of sigma. Sigma is very strong bond, pi bond is weak bond. Free rotation is possible about sigma, free rotation is not possible about sigma bond. And the sigma bond can be formed independently. Pi bond is formed only after the formation of sigma bond. These are the differences between sigma and pi bond. Okay. That is all about today's topic. Thank you.